Texan Global School. Trigonometric Identities. In this class, we will analyze proofs and tools to verify trigonometric identities. An identity is an equality that is true, or it is satisfied for every value of the variable. The identity symbol is presented on the board and reads, identical to. For example, the equality x minus 1. It is identical to 2x minus 2 over 2. We can see that any value that is substituted on both sides will satisfy the equality. For example, substituting by -1 or by 0, the identity is satisfied. Any other value such as 1. Even if we substitute by pi, the identity will be satisfied. This concept is the one we will use to verify trigonometric identities. We will prove that both sides are identical. We can see 8 fundamental trigonometric identities, which include reciprocal trigonometric identities, ratio trigonometric identities, and squared trigonometric identities. We can perform the proofs of some of these identities. For example, we will prove that sine of u times cosecant of u is identical to 1. Starting from the unit circle, with a radius equal to 1. We can see that the sine of u is the same with y, since the radius is 1. As seen above, the reciprocal of sine is the cosecant, therefore, it is equal to 1 over y, where y is equal to 1 over cosecant. By using equal value, we have that the sine of u equals 1 over cosecant of u. Therefore, sine of u times cosecant of u is identical to 1. We will now show that the tangent of u is identical to the sine of u over the cosine of u. Likewise, starting from the unit circle, results that the sine of u is equal to y, the cosine of u is equal to x, and the tangent of u is y over x. Substituting x and y in the tangent, results that the tangent of u is identical to the sine of u over the cosine of u. Finally, to prove that the sine squared of u plus cosine squared of u is identical to 1. Starting from the unit circle, we have that the sine of u equals y, and the cosine of u is equal to x, using the canonical form of the Searles, which is x squared plus y squared equals with r squared. Since the radius of the unit circle is 1, then the equation is transformed as x squared plus y squared equals 1. Substituting the values of the trigonometric functions x and y, results the sine squared of u plus cosine squared of u is identical to 1. To verify a trigonometric identity, we must select one side of the identity. Then, work with that side without altering the other. Transform everything in terms of sines and cosines. Use the fundamental identities to simplify. Let's see the first example. We have to verify the following identity. First, we select a side of the identity. It is suggested to choose the most extended side to simplify it. In this case, we select the right side. The other side is not altered. Now, transform everything into sines and cosines using the fundamental identities. The cotangent is transformed into cosine over sine. But, since it is squared, results cosine squared of theta over sine squared of theta. We perform the operation as fractions of 1 plus cosine squared of theta over sine squared of theta. Let's get the least common multiple, which is the sine square of theta. Hence, results sine squared of theta plus cosine squared of theta over sine squared of theta. We can see that the numerator, using the trigonometric identities, equals 1. So let's perform the product obtaining sine of theta over sine squared of theta. By simplifying, results 1 over the sine of theta, which by trigonometric identities is the cosecant of theta. So, the identity is verified since the right side is exactly the same as the left side. In this next example, we are also requested to verify the identity. First, select a side of the identity. It is suggested to choose the most extended side to simplify it. In this case, we select the left side. The other side is not altered. Now, transform everything into sines and cosines using the fundamental identities. The tangent can be transformed as sine over cosine. But since it is squared, results sine squared of x over cosine squared of x. To simplify, perform the operation as fractions of 1 plus sine squared of x over cosine squared of x. Let's get the least common multiple, which is cosine squared of x. So we have cosine squared of x plus sine squared of x over cosine squared of x. We can see that the numerator, using squared trigonometric identities, is equal to 1. By performing the product, results cosine squared of x over cosine squared of x, which is 1. Therefore, the identity is verified, since the right side is exactly the same as the left side. This same example can be verified by first applying a trigonometric identity to transform 1 plus tangent squared is identical to secant squared. Then, transform into sines and cosines, and simplifying to verify the identity. In this last example, verify the following identity. First, select a side of the identity. In this case, let us choose the left side. Since everything is already a function of sines and cosines, let us simplify. Using the trigonometric identities, we know that the sine squared of u plus the cosine squared of u is identical to 1. Hence, we deduce that the sine squared of u is identical to 1 minus cosine squared of u. By substituting, we can simplify identical factors. 2 divided by 2 is 1. Cosine divided by cosine is also 1. And sine squared over the sine is the sine of u. Therefore, the identity is verified since sine of u is identical to sine of u. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com